So now that I have fancy variable types that I can save data into, how is it that I actually do any kinds of calculations with that data? Really what we need are arithmetic operators to be able to do that. For everybody following along, that is page 62, and really we're looking at table 2.9. Really, the arithmetic operators are no different than you remember from grade school. Plus, minus, multiply, the ampersand, not the ampersand, the asterisk rather, division, divide, and modulus. This is the one that's a little maybe different than what you're used to. Some things to consider for everything as we're making an assignment that is an arithmetic assignment. We're actually doing math on something. We have the left-hand side of the equal sign and the right-hand side of the equal sign. The variable name on the left-hand side of the equal sign is where the result of the right-hand side is going to be stored. So make sure that when you are actually setting up your mathematical operation here, that the variable type you expect to accept that math is on the left, and all of the mathematical portions are over there on the right-hand side. We'll actually see in chapters 3 where you can kind of get the wrong idea and go in the wrong direction with this. But for right now, that's exactly what we're looking at. Really, everything functions the way you expect it to. If I was to have, you can see there on the table 2.9, total equals cost plus tax. What's going to happen here is when that particular line of code is being read by your compiler or during runtime, we're going to take cost, so that is a variable, and we're going to take tax, that's another variable, and we're going to take the value that is stored in cost, and we are going to add to that the value that is stored in tax, and that is going to be assigned to total when we're done. The very same thing for subtraction, multiplication, and division. All four of those arithmetic operators, plus, minus, multiply, and divide, are good on integer, short integer, float, double, long and short, double and float, the whole 9 yards. You're good to go for all of those, and they work exactly the way that you would expect. The very final one, on the other hand, does have a couple of conditions with it, and that is the modulus operator. Something to note, you can actually see that on the very bottom of page 62, is modulus only works on integer values. There is a little bit of a concern that you should have here for integer values, is the way that C++ looks at converting, let's say, a double to an integer. Now, let's say I have remainder, and that is what I'm going to use to assign the modulus, the remainder of two, let's say, double values. I have $2.99 for value, and I want to see the remainder after some mathematical operation is left on there. You and I, we have been socialized to look at the $2.99, 2.99, as a, in this case, the data type would be a double, let's say. And when I say, okay, let's look at converting that into an integer, you and I, we would look at that and say 2.99, that's really like 3. No, C++ does not do that. The conversion from a double to an integer does not round. It does not follow the rules of rounding. It is what is known as truncate. It's simply going to take everything after the decimal point and annihilate it. There will be nothing there. So 2.99 as a conversion from a double to an integer is simply 2. There are times where this is going to be okay, where you're not going to lose anything data-wise if you simply truncate your double into an integer, your float into an integer, but there are going to be times where that is not okay. If you are looking at, even a bank statement doing this, you could make the argument that, yeah, really, a customer is only losing at most 99 cents on a particular conversion. But really, that's not okay. If it was your money, if you were losing 99 cents every time the bank was doing a conversion from a floating point or a double into an integer, you would be angry. Even worse, if we have the conversion from a double or a float to an integer on something like a tax rate. 5.99% is truncated to 5. We are losing 1% there of the total tax rate that we can assign to something. So that is an issue. In any and all cases where you think you are going to do conversions from a floating point or a double into an integer, make sure that you are not concerned with everything that is happening to the right of that decimal point, because there is no exception handling. There is nothing that is going to happen inside of C++ that is going to preserve that for you. It is simply going to save that data, output that data, write that data to a file, do exactly what you've requested of it without letting you know, hey, are you sure you're okay with eliminating that 0.99 after the decimal point? That will not happen. So back to the modulus. If we were to have, like you see there on the bottom of page 62, leftover equals 17 percent sign, that's the modulus operator, 3. So that is 17 divided by 3 with whatever remainder is left as far as integers are concerned. So 5 goes into 17 3 times, and that's 15. So the remainder, the leftover, would get assigned the number rather 2. So that's something to be aware of. It's actually a really great operation to have if we're looking to do something like change. Because you can actually just use that modulus and go down from large bills all the way down into things like quarters, dimes, nickels, pennies, etc., and not have to do crazy amounts of calculation to have to remove more money to get down there. So those are your arithmetic operators: plus, minus, multiply, divide, and modulus.